Chapter 5, Section 3. We're solving systems of linear equations. We've been doing that, correct? What are the two methods I've used so far? We've used substitution. Yesterday and Friday we used substitution. We substituted an expression for one of our variables, and that helped us get one of our variables. And then we were able to plug in that variable and get the other variable. Because which variables do I need? I need an x value, and a y value because my answer is an ordered pair. Everyone still remember that from systems of equations. So today, same thing. We're going to need an x value and a y value because it's going to be an ordered pair. What was the other method we used to solve systems of equations? No, we already talked about substitution. When we did Wednesday, Thursday, and Tuesday, and spent a lot of time on it. Starts with a G. Graphing. Solve systems of equations by graphing, correct? We graphed the two lines on the same graph. What was my answer? The point where they intersected each other, right? So the ordered pair where the two graphs crossed each other was my solution when I was solving by graphing. We okay with that? Today we're talking about the last method, which is called elimination. So we're probably going to be eliminate something during this process. Okay? So here's the steps. Write them down. I'm going to give you time to write them down. As y'all are writing these down, I'm going to kind of talk through them a little bit. Step 1, line up your x values, your y values, and your constants. So usually we're given our systems of equations stacked on top of each other, correct?
Yes.
So, that's just saying, line up your x values, line up your y values, line up your constants. A lot of the times it's already done for you, so a lot of the times we don't have to worry about step 1. Step 2, multiply, if necessary, one or both equations by a constant, so at least either the coefficients with the x terms or the coefficients with the y terms are the same number with opposite signs. So that's my goal when I'm trying to eliminate one of my variables. In front of my variables, I need the number to be the same with opposite signs. What do I mean by same number, opposite signs? Give me an example. Anyone have any examples for me of things that are the same number, opposite signs? What? Yeah, so give me an example. Yep, negative 1 and 1. Same number, opposite signs, right? Positive 3, negative 3. Positive 7, negative 7. Negative 10, positive 10. Do you all get what I'm saying when I say same number, opposite signs? I need to have same number, opposite signs in front of one of my variables in order to eliminate that variable. Step 3, once I get the same number, opposite signs, I can then add my equations to eliminate the variable that has the same number with the opposite sign. Because if I add two numbers that are the same number with opposite signs, what happens to them? Say I add 2 and negative 2. What do I get?
You get a positive?
Nope.
Oh, a negative.
2 plus negative 2, negative 3 plus 3, 10 plus negative 10. What do I get with all those? If I have 3 and I add negative 3 to it? 0, right? That's why this is called elimination, because when I get that same number opposite sign, it eliminates that variable for me. Step 4, once I eliminate a variable, I will get an equation, and so I need to solve the resulting equation for whatever variable I have left. So if I eliminate x, I'll be solving for y there. If I eliminate y, I'll be solving for x there. Step 5, just like we've been doing in the past, substitute the value from step 4 into one of the original equations and solve for the other variable. Because we've got to get both x and y, correct? So once I find one, I got to plug it into an equation to get the other. I know we're still writing, but do we have any questions about any of these steps? Okay, I'm going to give you a little bit more time to write. Okay, moving on to our examples. Example 1, solve the system of linear equations by elimination. Negative 5x plus 2y equals negative 20. 5x plus 2y equals 40. What does step 1 tell me to do? Line up x, my y values, and my constants. Are my x values lined up? Yep. Are my y values lined up? Are my constants lined up? Yep. Like I said, most of the time it'll be done for you. There may be some times where I need to do it myself. If that's the case, you may have to use your inverse operations to move things from one side of the equation to the other to be able to line them up. Does that make sense? Okay, so step 1 done. Step 2, what does it say?
Multiply and reduce one of both equations by a constant so that at least the other coefficient with the x terms of the coefficient with the y terms are the same for the opposite sides.
Very good. In front of x or y, I need the same number with opposite signs. So do I have that right off the bat?
No.
I heard yes, I heard no. Do I have same number opposite signs in front of either variable? Which variable? X. I've got a negative 5 and a 5. That's the same number opposite signs, right? So do I need to multiply by anything here? Nope. Last step says if necessary. If you already have same number opposite signs, you don't have to multiply by anything. Okay? After step 2, what does it tell me to do? Step 3.
I have the equation to eliminate the variable that has the same number with the opposite sign.
Very good. Once I have same number opposite signs, I can add my equations. And like we said earlier, negative 5x plus 5x gives me 0x. So they are eliminated, my 5x's. For now, we'll come back to the x's. 2y plus 2y, 4y, equals negative 20 plus 40. 20. Does everyone see how elimination has helped us? It eliminated a variable for us, so I can now solve for the other variable. Because now I just have an equation that has just y in it. So now I can solve that equation for y. How do I do that? Divide by 4. What does y give me? 5. 20 divided by 4 is 5. There's my y value for my ordered pair. Am I done? No, that's only step 3 or 4.
No, that's step 3.
That was step 3, solving the equation for the variable. That's 4.
It's step 3.
Okay, what does step 5 then say?
Substitute the variable from step 4 to one of the original equations and solve for the other variable.
Yep, so I get to plug 5 in for y into one of my equations. Do you think it matters which one? No, I can use either one I want. You guys want the first or the second? First. Wait, what?
Second.
You guys want second?
Yeah.
Second. You can use either one you want. You'll get the same answer either way. 5x plus 2 times y. What's my y value?
5.
5 equals 40. Now I just have an equation with x in it, so now I can solve for x. 2 times 5. 10. So 5x plus 10 equals 40. Solving for x, what's my next step? Subtract 10 from both sides. 40 minus 10. 30. My last step to get x by itself. Divide by 5 on both sides. So x equals 30 divided by 5. 6. Questions how I got x equals 6? How do I want you to write your answers? As ordered pairs. So how would I write my answer here? 6 comma 5. Would it be acceptable to put 5 comma 6? No. You got to have the x value first, y value second. There's my answer. Does this tell me to check my solution? No. If it tells you to check your solution, do I want you to check it?
Yes.
Yes. Are we all okay checking our solutions, or do I need to go through that with you again one more time? If we're all confident with it, I'll skip it. We're all confident plugging in our answer and checking our solution. So I don't need to do it. If someone needs me to do it, I'll do it. Okay, let's do it. I'm going to do it for this one. Which equation do I check? I've got to check both of them, because it's got to be true for both of my equations for it to be a solution of my system, correct? So negative 5 times x, what's x? 6 plus 2 times y, what's y? Equals negative 20. Once I plug in, I'm just working down both sides of the equation. What's negative 5 times 6? Negative 30 plus 2 times 5? 10 equals negative 20. Negative 30 plus 10? Negative 20. Does negative 20 equal negative 20?
Yes.
Yep, it's a true statement, so it works for my first equation. But now, I've got to check my second equation as well. Once again, plug in your ordered pair. What's the x value? 6 plus 2 times y. We said y was 5. Equals 40. 5 times 6? 30. 2 times 5? 10. 30 plus 10. Does 40 equal 40? Yep. Since it checks out for both my equations, does that mean this is a solution to my system or not? Yes, it is. If it asks you to check your solution, check it. Questions about that? Can I move to my next one? Six x plus 4y equals negative 46. 2x plus 4y equals negative 26. Okay, step 1. Is everything lined up where it needs to be? Yep. My x values are lined up. My y values are lined up. My constants are lined up. We okay with step 1? Step 2. See if the coefficients in front of x or y have same number opposite signs. Do either x or y have same number opposite signs? No, they do not. Am I close to same number opposite signs? Yes, I am, right? The y values have the same number. They just don't have opposite signs, do they? So any ideas what I can multiply one or both of those equations by to get one of those as a negative 4y? What? Negative 1. Very good. Do I need to multiply the top or the bottom by negative 1? Bottom? Does it matter? No, it doesn't. Because I just need the same number opposite sign. Doesn't matter if the opposite sign's on the top or the bottom. So, one of the biggest mistakes I see with elimination, when you multiply, everything in that equation has to be multiplied by that number. Every single thing. X value, Y value, constant, every single thing. Some people don't do that. Some people forget to multiply the constant by the negative 1 here. Negative 1 times 2x. Negative 2x. Negative 1 times 4y. What? Negative 4y. Negative 1 times negative 26. 26. We okay with what we've done? Like I said, we could have multiplied the top by negative 1 if we wanted to as well. Okay, do I have same number opposite signs now?
Yes.
Yes, I do. So now I can do what with my two equations? Add them together. The only problem is I've got 3 equations now. Which 2 am I adding? Say it again. The very bottom one and my top one. Because my bottom one is equivalent to that second one, but it helps me out more. And then I got to use the one that I haven't even touched yet. Okay? So what's 6x plus negative 2x? 4x. What happens with the y values? They're eliminated. Negative 46 plus 26. Nope. No. No. Negative 46 plus 26. Not 20.
You said -46 plus 20?
Negative 46 plus 26.
Negative what?
What?
Negative what?
Negative 20. We okay with that? How do I get x by itself?
Divide by 4.
Divide by 4 on both sides. What does x equal?
-5.
Negative 5. Very good. Questions there? So there we had to multiply one of our equations by something. Sometimes you're going to have to multiply both equations by something. We'll see an example here in a little bit. What do I do with that x equals negative 5? Plug it in. Now, I've got 3 equations. I can actually use any of those 3 equations to plug it in. So y'all want 1, 2, or 3? 1. So 6 times x, what's x?
5.
Negative 5 plus 4y equals negative 46. Am I moving too fast for anybody? I can slow down if I need to. Sarah, get up, please. Thanks. 6 times negative 5. Negative 30 plus 4y equals negative 46. Can I combine negative 30 and 4y? No, so what's my next step to get y by itself? Add 30 to both sides. 4y equals, what's negative 46 plus 30?
16.
Negative 16. And last step to get y by itself. Divide by 4. What does that give me for y?
Negative 4.
Negative 4. So what is my answer here?
Negative 5, comma, negative 4.
Negative 5 comma negative 4. Questions how I got that? If they ask you to check your solution, do I want you to check it? Yes, I do. Any questions on example 2? How we feel about elimination so far?
It's not bad.
Not bad?
I think it's easier than substitution.
It can be kind of a tedious process a little bit, but
It was easier than what we did before.
you think it's easier than substitution?
Yes.
Okay. That's surprising. Can I move on to example 3? X minus 6y equals 44. 9x plus 12y equals 0. Let's get it written down real quick, then we'll go through our steps. Is everything lined up where it needs to be? Yes, it is. I got my x's on top of each other, my y's on top of each other, and my constants on top of each other. Step 2, do I have same number, opposite sign in front of my x's or my y's? No, I don't. Am I close to it like I was on the previous example, where they're the same number but not opposite signs? No. So what are the coefficients in front of my x values? 1 and 9, right? Can I multiply 1 by anything to get to 9, or 9 by anything to get to 1? Yeah, I can multiply 1 times 9 and get it to 9, right? To where I'd have the same number. And I'd have to multiply by negative 9 to make it opposite signs, right? Okay. Do what? Oh, I'm sorry. Let's look at our y values. Negative 6 and 12. Can I multiply 6 by anything to get to 12, or 12 by anything to get to 6?
Yes.
What can I multiply what by?
6 by 2.
I can multiply negative 6 times 2, and that'll give me negative 12, right? So would you rather multiply the top equation by 9 or by 2? Or I mean negative 9 or by 2? Probably 2, because it's a smaller number, right? I like to deal with as small of numbers as I can deal with. If I multiply by 9, I'm going to get a huge number. especially when I multiply by 44. Right? You could still do it that way if you wanted to. If you like to deal with big numbers, that's fine. You can multiply by negative 9 at the top all you want. You should get the same answer we're going to get. But we're going to multiply the top by 2. Does everyone see why we're multiplying the top equation by 2? So I can get the same number, opposite signs in front of my y variables. Does that make sense? Okay, 2 times x. 2x. 2 times negative 6y. Negative 12y. 2 times 44. 88. We good with me multiplying 2 through the top equation? Now, do I have same number opposite signs in front of either variable? What? Yes, I do. In front of my y values. Now that I have same number opposite signs, I can now add my 2 equations. We're good there. 9x plus 2x. 11x. What happens to my y's? They're eliminated. 0 plus 88. 88. We've eliminated y. Now we can solve for x. How do I get x by itself? Divide by 11. What does x equal? 8. 88 divided by 11 is 8. Questions how I got x equals 8? We're still good with elimination so far. Okay, I can pick any of the 3 equations I want. Do you want first, second, or third to plug 8 into? First. So replace your x with 8. And now we're solving for y. It's my first step to get y by itself. Subtract 8 from both sides. Negative 6y equals what's 44 minus 8? Not 56.
36.
36. Very good. And how do I get y by itself? Am I moving too fast for anybody? I feel like I'm blazing through this. How do I get y by itself? Divide by negative 6 on both sides. Y equals negative 6. So, Sarah, what's my answer here? What's my ordered pair?
8 and negative 6.
8, negative 6. Very good. Questions how I got that. Good job. If it asks you to check your solution, do you need to check it? Yes, you do. Don't say no. Yes, you do. If it asks you to check your solution, check it. Questions on example 3? Example 4. We're just killing these examples, aren't we? Yeah, I can go ahead and write it. Negative 5x plus 8y equals negative 6. 4x plus 9y equals negative 26. Does everything line up where it needs to be? Yes, everything is lined up where it needs to be. Do I have same number opposite signs right off the bat? No, I don't. So let's look at our x coefficients, negative 5 and 4. Can I multiply negative 5 by anything to get to 4? No. Can I multiply 4 by anything to get to 5? No. Can I multiply 8 by anything to get to 9? No. Can I multiply 9 by anything to get to 8? No. Since that is the case, we're going to have to end up multiplying both equations by something to get same number opposite signs. Does that make sense? All the problems we've done in the past, we've had to either multiply none of our equations or just one of our equations. Now we've got to multiply both of our equations by something. Does that make sense? Okay, negative 5 and 4. Whenever we're looking to figure out what we're going to multiply our equations by, we like to look at our least common multiples of our coefficients. What do I mean when I say least common multiple? Okay, well, what are multiples of 5? 5, 10, 15, 20, so on and so forth, right? What are multiples of 4? 4, 8, 12, 16, 20, 24, so on and so forth. So I want to find the smallest number that they both go into. So what's the smallest number that both 5 and 4 go into? 20. So if I'm trying to eliminate x, I would need to get 20 in front of my x variables. What would I have to multiply the top by to get negative 5 to 20? 4. What would I have to multiply the bottom equation by to get 4 to 20? 5. So I'd have to multiply by 4 and 5. Right? Let's look at y. See if there's any smaller numbers we can do. 8 and 9. What's the least common multiple of 8 and 9? 72. What would I have to multiply the top by to get 8 to 72? 9. What would I have to multiply the bottom by to get 9 to 72? 8. So would you rather multiply by 9 and 8 or 4 and 5? 4 and 5. Me too, all day long. 4 and 5. So which variables are we going to eliminate here? X. Could I eliminate y if I wanted to? Yeah, I could. Doesn't matter which one I eliminate. I just like to deal with smaller numbers. That's why I'm multiplying by 4 and 5. If you multiplied by negative 9 and 8, you should get the same answer that we get. Okay? So what are we multiplying the top by? 4. 4 times negative 5x? Negative 20x. 4 times 8y? 4 times 8y? 32y. 4 times negative 6? Negative 24. Do not forget to multiply that constant by the number we're multiplying the equation by. What are we multiplying the bottom by again? 5. 5 times 4x? 20x. 5 times 9y? 45y. 5 times negative 26? Negative 130. Questions how I got any of that? Or why I did what I did? Do I have same number opposite signs now? Yeah, now I can add my two equations. What happens with the x's? Eliminated. Negative 20x plus 20x is 0x. 32y plus 45y. 77y. And negative 24 plus negative 130. Negative 24 plus negative 130. Negative 154. How do I get y by itself? Divide by 77 on both sides. Y equals negative 2. Questions how I got that there? Do you want to plug into the first, second, third, or fourth equation? Please don't pick 3 or 4. We can use those if we want, but those are really big numbers. 2. 4x plus 9 times y. What's y? Negative 2 equals negative 26. 9 times negative 2. Negative 18 equals negative 26. What's my next step to get x by itself?
Add the 18 to
Very good. Add 18 to both sides. 4x equals, what's negative 26 plus 18?
negative 54.
Nope. Negative 26 plus 18. What? Negative 8. Sorry. How do I get x by itself? Divide by 4 on both sides. X equals negative 2. Questions how I got x equals negative 2? So what's my solution here? Wait, no, flip them. Remember, x comes first. That was pretty funny, wasn't it? Did everyone get the joke, or do I need to explain it real quick? You didn't get it? Okay. It was funny, wasn't it? Third hour didn't think it was that funny either. First hour, they liked it. First hour liked it. So, questions on example 4? Can I move on? Let's keep killing it. We're just blazing through this. This is good stuff. Excuse me. 2x plus 2y equals 6. 5x plus 3y equals 13. Are they lined up where they need to be? Yes, they are. Do I have the same number opposite signs anywhere? No. Okay, looking at 2 and 5, my coefficients in front of x. What's the least common multiple of 2 and 5? 10. So, one of those would have to be negative, right? So what would I multiply the top by to get 2 to 10? Negative 5. What do I have to multiply the bottom to get 5 to 10? 2. So 5 and 2 are negative 5 and positive 2. Positive 5, negative 2, one of those combinations. 2 and 3 on y. What's the least common multiple of 2 and 3? 6. What do I have to multiply 2 by to get to 6? 3. What do I have to multiply 3 by to get to 6? 2. So would you rather multiply by 5 and 2 or 3 and 2? What? 3 and 2? So which variable are we eliminating if we're doing that? Y. Remember, one of them does have to be negative, so I can get opposite signs. So what am I multiplying the top by? What? What'd you say? I can't hear you.
2.
Not 2.
Negative. Wait.
What am I multiplying the top by to get 2 to 6? 3. What am I multiplying the bottom by? Negative 2. Because one of them has to be negative because they have the same signs right now. If I wanted to, could I have done negative 3 and positive 2? Yeah, I could have. Yeah. Just one of them has to be negative. It doesn't matter which one. 3 times 2x. 3 times 2x. 6x. 3 times 2y. 6y. 3 times 6. 18. Y'all don't fall out on me. This is our last example. Negative 2 times 5x. Negative 10x. Negative 2 times 3y. Negative 6y. Negative 2 times 13. Negative 26. Do I have the same number opposite signs now? Okay, do I have the same number opposite signs? Yeah, I do. 6x plus negative 10x.
Oh, that.
Negative 4x. Y's are eliminated. 18 plus negative 26. What is it? 18 plus negative 26? Negative 8. How do I get x by itself? Divide by negative 4. X equals? Positive 2. Questions how I got that? Do you want to use 1, 2, 3, or 4? 1. Great, thank you. X value is 2, so I'm plugging 2 in for x. Plus 2y equals 6. 2 times 2? 4. Next step to get y by itself. Subtract 4 from both sides. I'm trying to hurry, I gotta get you your assignment. 6 minus 4.
Dang it.
2. How do I get y by itself? Divide by 2. What does y equal? 1. What's my solution? 2 comma 1. Very good. Any questions? I got that on example 5. How do we feel about elimination? After doing all 5 examples.
Good.
Good. That's what I like to hear. Make sure when you're eliminating a variable, you get the same number opposite sign in front of that variable that you're eliminating. Once you get the same number opposite sign, you can add your equations to eliminate that variable. Then solve for the remaining variable. Once you get that variable, plug back into one of your original problems and solve for the variable you have not found yet. You have to get x and y. Your answer has to be in ordered pair. Any questions on that? Questions about any of the notes we just took? Okay. We'll get the assignment in class tomorrow.